Quat versus high alcohol in surface disinfectants. In this webinar, you'll learn how to answer the question, what is quat? You'll learn about the history of quat and how it works. You'll also learn about different quat disinfectant chemistries, CaviWipe surface disinfection, and some additional resources from Metrex. Our belief here at Metrex is that no one should ever have to fight for their health over an infection they didn't have when they entered a healthcare facility. Our vision for the future is a world without any preventable healthcare-associated infections, or HAIs. Our mission at Metrex is to protect people by working tirelessly to support healthcare professionals in the fight against HAIs so that your time, energy, and focus can be put on the most important thing, getting the patient better. The pillars of our mission are our people, our team here at Metrex that lead with integrity and passion, our quality Metrex products built from customer needs, and our partnerships. And that's partnerships with people like you watching this webinar, looking to gain insight on quat and its role in the fight against HAIs. So let's answer that first question that's top of mind. What is quat? Quat is short for quaternary ammonium compounds and is sometimes written as QAC in literature, but more often it's shortened to quat, spelled QAT in conversation. There's your answer. More than a century ago, quaternary ammonium compounds were discovered to have antimicrobial properties. Today, quat is commonly used to clean non-critical patient care equipment. The photo shown here is a typical schematic of a quat compound. You can see the nitrogen atom in the middle, depicted by the capital letter N. This central nitrogen atom is attached to 4 groups or 4 chains. This is the quaternary feature of quat. The word quaternary stems from the Latin word for 4. Another important note that we'll talk more about in a bit is that plus sign above the central nitrogen atom. The 4 chains attached to that nitrogen gives this molecule a positive charge. Lastly, before we leave this quat schematic, notice that the number of carbons denoted by the capital letter C can vary in length for the chain on the right side that has a C with a subscript lowercase n. The different types of quat used in chemistry is differentiated by the length of that side chain, or the number of carbons in that side chain. But the defining characteristic that makes a molecule a quat molecule is that nitrogen atom attached to 4 carbon groups. So quat has a positive charge and 4 chains. That's why quat is quat. Keep this in mind because we'll come back on the subject of how quat works to kill germs in a bit, and you're going to need this information. Let's briefly talk about the history of quat. Why do we use quat to disinfect things, and how did we come to use it in that way? It all started over a century ago when people found that quat has germicidal properties in 1916. Almost 20 years later, in 1935, the first commercial quat-based disinfectant product was invented and brought to the cleaning and disinfection market. Then another 20 years later, the synergistic efficacy that comes from the combination of quat with alcohol was discovered in 1955. It was known at that point that alcohol has antimicrobial properties as well. The beauty of combining the 2 germicides together is that the disinfectant becomes much more powerful. A single quat ingredient on its own isn't able to deactivate difficult pathogens, such as TB. But when mixed with even a small amount of alcohol, that's when the magic happens. Over 40 years later, this quat and low alcohol chemistry was harnessed to create Metrex's first surface disinfectant, Cavicide, in 1998. Since then, Cavicide has been tried, tested, and trusted in the clinical market for over 20 years. So we know what quat is and its history. Now the question is, how exactly does quat work? Well, the working mechanism for quat could be very complicated, but we can simplify and try to summarize it into 3 pictures. Let's look at the first picture. The little orange guy on the left is a quat molecule. There it is with its 4 chains that we learned about. The bacterial cell pictured next to the quat molecule is your typical pathogen. What you need to know about most pathogens is that in a neutral, normal bioenvironment, the surface of most pathogens is negatively charged. So the cell wall of this big bad bacterial cell is negatively charged, and our little quat molecule is positively charged, as we learned. Well, opposite charges attract. So the quat and the bacterial cell membrane are going to be attracted to each other and find each other really quickly. In the second picture, you can see the quat molecule actually punctures the wall with its side chains. These side chains of quat molecules are usually hydrophobic, meaning they try to escape from water. This is the same with the bacterial cell wall. They are also hydrophobic. So the hydrophobic chains of the quat molecule penetrate into the hydrophobic cell wall and cell membrane of the pathogen as it tries to escape the surrounding hydro environment and sneak in with its hydrophobic friends in the cell wall. In the last picture, you can see that the puncture created by the quat molecule causes cell liquid like cytoplasm to leak out of the cell. This eventually leads to the death of that cell. And that's how quat works to kill germs like bacteria. With our basic quat questions answered, let's take a look at how quat is used in our clinical lives. Quat is a very important ingredient in many surface disinfectants. There are so many surface disinfectants on the market. A topic we talk about often in Metrex is how to go about choosing the right surface disinfectant. Shown here are 6 key factors. First, we have broad spectrum of efficacy. A product that has efficacy against a spectrum of pathogens, including bacteria, viruses, fungi, and in healthcare you need to look for a TB claim too. The quality of efficacy claims over the quantity of efficacy claims is another key factor. Just because a product has 100 claims doesn't mean that it has the clinically relevant claims important to your facility. Another key factor is cleaning property. You cannot disinfect a surface if it hasn't been thoroughly cleaned, which we'll talk a little more about later. Our next key factor is contact time. A reasonable contact time ensures compliance and will help impact staff efficiency. Compatibility and aesthetics make up another key factor. This involves selecting a product which has active ingredients that are the right fit for the areas and environment in which they are being used, and which won't impact aesthetics. Last but not least is safety. Is the product flammable? Does the product require additional PPE? Is it carcinogenic? Etc. These factors can help you navigate through the variety of disinfectants available to you. Next, let's look at the pros and cons of some different quat chemistries. First, we'll look at high alcohol quat chemistries. High alcohol quat formulas are often broad spectrum, including non-enveloped viruses. They also often have a short contact time. However, high alcohol quat formulas are often not effective cleaners and are unable to remove bioburden off of surfaces. They can even lead to protein fixation. High alcohol quat formulas may dry prior to contact time due to the high alcohol content and the quick evaporation of alcohol. Alcohol may also damage equipment, especially plastics, leading to cracking and damaging. Some examples of high alcohol quat products are Super Sani Cloth with its 55% alcohol, Sani Cloth Prime with 56% alcohol, and Microkill 1 with 72.5% alcohol. I mentioned how one of the big disadvantages of high alcohol products is that they are typically not effective cleaners. Let's talk a little more about why that matters. A common belief is that surface cleaning and surface disinfection are synonymous. These two terms represent unique and independent functions. Cleaning represents the removal of visible soil contamination and gross debris consisting of such things as blood, mucus, and other body fluids from environmental surfaces and fomites. Disinfection is the process used to kill infectious organisms on these surfaces with the intent of preventing cross-contamination. Soils encountered in clinical applications, such as blood and mucus, tend to have high concentrations of proteins and fats. These can interfere with the surface disinfectant liquids by preventing contact with the surfaces which require disinfection. When this situation occurs, the surface is not fully wetted with the disinfectant, thus protecting the microorganisms from inactivation. Metrex conducted an internal cleaning evaluation seen here. Blood-based fatty soils were applied to stainless steel test coupons. The soil was allowed to dry and the coupons were then subjected to a standardized soil removal protocol. CaviWipes 1 and CaviWipes, two low-alcohol Quat Metrex products shown at the top, exhibited good soil removal. One wipe with the machine successfully removed the soil from the surfaces of the test coupon, leaving the stainless steel clean. Wipe products A, B, and C exhibited poor soil removal in the study. The high and intermediate content of alcohol, the 63%, 55%, and 42% alcohol in these products, caused the proteins in the blood-based soil to affix onto these test coupons. CaviWipes and CaviWipes 1, with their lower alcohol content of 17% and 22% respectively, along with product D, which was hydrogen peroxide based, did not exhibit the same concern as the higher alcohol products. So disinfectant products not only need to disinfect well, they should clean well. This is why cleaning properties are one of our 6 key factors for choosing a surface disinfectant. So I introduced you to another Quat chemistry combo, which is Quat plus low alcohol. Low alcohol Quat products typically are effective cleaners and often demonstrate good material compatibility. They are also likely to remain wet for the full required contact time. However, a disadvantage of this chemistry is that it can be less efficacious against non-enveloped viruses. Some examples of low alcohol Quat products are Sanicloth Plus, Opticide, Opticide Max, and Metrex Surface Disinfectants CaviWipes and CaviWipes 1. The last Quat chemistry we want to cover is alcohol-free. These formulas rely on a Quat only as their active ingredient. These products are often compatible with alcohol-sensitive materials and devices. However, alcohol-free products often leave residue and may be less efficacious against non-enveloped viruses. Two examples of alcohol-free products are Sanicloth AF3 by PDI and VersaSure by Clorox Healthcare. Before we wrap up our Quat discussion, I want to share with you more about our Metrex Surface Disinfectant line of products. This is the CaviWipes family of products. On the left, you have our 1-minute product, CaviWipes 1. This is a fast-acting product with aggressive efficacy. In the center, you have our workhorse, our 3-minute CaviWipes Classic product that is gentle on surfaces with great material compatibility. On the right is CaviWipes Bleach. CaviWipes Bleach is not a Quat-based disinfectant, but it is our bleach wipe by Metrex for all your bleach sporicidal needs. Metrex also offers additional support materials for surface disinfection in your facility. First, we have these placards shown here. They can be attached to equipment throughout your facility, showing which disinfectant should be used for each piece of equipment, and also noting the proper contact time for the disinfectant. You can get these visual cue cards by contacting your local Metrex sales rep. In addition to those visual cue cards or instruction cards, we have various wall charts available, again from your Metrex sales rep. You can also go to our website, metrex.com, to see all the material we have available for you and distribute them to your staff. Lastly, I want to thank you for viewing our educational webinar about Quat. Please check out all our Metrex webinars, particularly our Webinar Wednesday lineup. You can check out all our webinars and register for our next live session at metrex.com. Metrex, Infection Prevention,